Continuing on with limits, in the last video I defined them for you and I tried to help you by giving you some visuals and I left you with an example. So let us go back to this example here and let us see if we can come up with all of these answers over here on the left, A through F. Again, let me just remind you of the definition of limits. The formal definition is we're looking for what our f of x is getting closer and closer to as our x value gets closer and closer to that specific x value here. So I just want to remind you that limits describe the behavior of the function near a particular point. What's happening from the left of this point, what's happening from the right of this point, not exactly what's happening at the point itself. Now, of course, there can be a point defined there that doesn't give us any indication what the limit is. That's only what the function is defined at. We just want to know what's happening as we approach that point from both directions at the same time. If my left direction and my right direction don't match up, then my limit does not exist, and we're going to abbreviate that as a D and E here. So let's go back to this example, and let me start with the easy ones. So one of the easiest ones here is probably part F. The limit as x is approaching 12. So I find my x value of 12, and I want to see what my graph is doing as I get closer and closer and closer to the left-hand value and closer and closer and closer to the right-hand value. Now, there is a specific point defined here. Doesn't do us any good whether it is or isn't defined, but I want to figure out what this y value approximately is. So I trace it over here to my y value, and it looks to be about somewhere around 3. So my limit of h of x, which is this graph here, as x approaches 12 is my 3 value, because that's what's happening as I get closer and closer to it from opposite directions. And let's pick out another easy one. So my next easiest one might be C. What's happening as x is approaching 2? Again, I look at 2, my x value, as I get closer and closer and closer to it from my right-hand side, and closer and closer and closer to it from my left-hand side. Both of those end up at this specific point right here. If I trace that over to my y value, I see my y value is equal to 1. So my limit of h of x as x is approaching 2 is equivalent to 1, because my graph gets closer and closer to that value from both sides. So another easy one would be part D as x is approaching 3. So I find that on my x value, and I trace that up here to meet my graph like I did in the visuals of my last video. I want to figure out where I land at. So again, I follow my graph closer and closer and closer to the left-hand side and to the right-hand side, and I end up with something around here. So if I trace that over here, that gives me something close to my 9 value. So my limit of h of x as x is approaching 3 is equivalent to 9. So I look at where my graph is headed from both directions, and I figure out where that y value ends up at. Now, these were easy examples because all of these examples had points defined. Whether they were specifically notated, like in 12, I had a specific point there, or whether they were not specifically notated, like it was at 2 or 3, but I still have points on my graphs there, so all I have to do is come up with my y value that matches along with them. Now let's see what happens when I don't have specific points there. And remember, the points are where my function is defined, and that's not what we care about at this moment. We care about where my graph is headed, because that's how limits are defined. So let's do the other ones just in alphabetical order. So let's focus on example A now. Okay. In example A, I'm looking at my x value of -4, which is here, and I figure out how that meets up with my graph. So I trace my graph from the left, and I can see it's approaching this value right here. And I can trace my graph from the right, and I can see that it's approaching this value right here. So if I trace my graph from my left and I trace my graph from the right, I end up at this place right here, which is 6. So my limit here is defined to be 6. Now notice I have a point up here. That's where my function is defined. So if I wanted h of -4, my function, that value would actually be 10. That's where my function is defined. I don't care about specific points in themselves. I care about where my graph is leading me to. And my graph leads me to this place right here, so that's why my limit is defined to be 6. Okay, let's move on to example B. That is looking for x is approaching -2. So I find -2, and I trace my graph from the left of -2. So from the left of -2, my graph is leading me to this point here. And I trace my graph from the right of -2. And that is leading me to this point here. Notice my left lead and my right lead do not end up at the exact same spot. And that goes back to one of the hints that I gave you. The limits from the left need to equal the limits from the right, otherwise my limit does not exist. So when I traced my graph from opposite directions, I did not end up at the exact same place. So my limit as x is approaching -2 of h of x does not exist. Notice it does not matter where my point is defined. If I erase all this scratch work here, my point is defined down here. Again, that's what my function is. So if I wanted h of -2, that would be where this red point is defined, which is probably somewhere around to be -1. I don't care about the point. I care about where my graph leads me, and it leads me to opposite places in opposite directions. Hence, my limit does not exist at -2. All right, I have one more example. And this one is as x is approaching 6, so I find 6. I want to know where my graph is headed from the left, so if I trace it from the left-hand direction, it leads me to this here. If I trace it from the right-hand direction, it leads me to this here. Of course, they do not meet at the same y value. One leads me to a y value of 4. One leads me to a y value of 2. They do not meet up, so my answer to part E is my limit does not exist. They have to match in both directions. One more time, I need to remind you it does not matter where my point is. That is where my function is defined. So if I wanted h of 6, that would be where this point is defined, and that is around here at 3. So my function h of 6 is equal to 3, but my limit as x is approaching 6 does not exist because they don't match from the left and from the right. Hopefully, I've given you enough unique examples here to figure out limits now given a visual of the graph. In the next video, I'll tell you how to compute limits using actually algebraic material and not just visuals like we've seen so far.